Welcome back to the SEI Agile Research Forum, meeting the challenges of large-scale systems. Our next presentation is Strategic Management of Architectural Technical Debt by Ipek Ozkaya. This presentation will conclude with an open dialogue period during which you can ask questions directly to Ipek. We will address as many questions as time allows. As a senior member of the SEI technical staff, Ipek is a co-organizer of the third International Workshop on Managing Technical Debt, co-creator of the Hard Choices board game, and frequent presenter at academic and industry conferences, and author of several articles. Ipek, all yours.
Thanks, Shane. Thanks everyone for listening in this afternoon. What I'm going to present today is our continuing focus on trying to understand the foundations of managing technical debt. We've been increasingly seeing an interest in understanding the software engineering foundations, as well as being able to quantify technical debt, both from the Agile community, but also from the community who's trying to adopt Agile techniques. As we've seen in Marianne's polling questions, for those of you who were listening in, a large portion of our listeners today have expressed that they have challenges adopting Agile software development techniques at their large-scale systems and organizations. And oftentimes what we observe is the reason for being driven to Agile techniques is observing increasing technical debt in their systems. So to go back to the initial foundations, in fact, in 2012, we are about 2 decades after the first time the metaphor was coined by Ward Cunningham, who described, well, you can ship first-time code and try to accelerate delivery, but that speed might actually come back with a need to re-engineer, refactor, or recode some of the aspects of the system. The question I'm posing today to all of us is, can we really avoid technical debt, especially in the kinds of systems that we see today? And I bring how architecture could actually help us in trying to understand this question better. And what we see both in our DoD stakeholders, but also our commercial stakeholders, and also we've seen that a majority of our listeners today are both commercial industry contractors as well as consultant space, which they might actually see the challenges that we see as well. First of all, there's an increasing scale of systems. This doesn't only include software systems, but there's an increasing reliance of other aspects, system of systems, and hardware and embedded systems that become a pervasive part of our day-to-day operations. Systems are expected to be in operation and sustainment for decades. It's not just that they're throwaway, but they will be maintained for long periods of time. And lastly, there's heterogeneous and uncertain workforce. There are distributed teams that we need to manage, and there are also the teams that are together are not only the cross-functional teams that we expect from a software engineering lifecycle function, but we need to also interact with other domain expertise, especially systems engineers and verification and validation and assurance parties. When we bring all of these together, it actually turns out that technical debt will accumulate even if we did not intend to. Environments will change, systems will change, technology will change, and it becomes actually an ongoing software engineering practice, if you will, that we need to have a grasp over. So the question that I will pose is, well, maybe it is time to move away from the metaphor, but really go to the foundations of the technical debt as an analogy, understand the financial implications that come with the analogy as a structural aspect of debt, which includes what's the interest rate that we're signing under? Can we actually control the interest rate? What is the time of the loan? What is it that we're borrowing? Is it only time, or is there other opportunities that we will need to bring to bear in terms of managing the timeline of the loan? And also, how do we actually create a payback strategy? So from that perspective, what I will try to walk you through is trying to understand how and when the debt was signed under, what is the payback term, and what is the interest rate. So the overall question that we're asking is, from an architectural perspective and from a system perspective, how do we actually describe and maybe in some cases even quantify the debt so that we can have a continuing strategy to monitor it better throughout the system lifecycle. Of course, I am not the first one to talk about technical debt, and I will stand on the shoulders of the industry thought leaders, but I would like to make sure that we have a common understanding of where we're coming from. Steve McConnell actually did a very nice taxonomy in terms of describing the types of debt that we deal with. Unfortunately, to date, a lot of the focus mostly has been on the unintentional, non-strategic kind of debt, which Steve McConnell describes as type 1, which is a result of poor design decisions and poor coding. That will always be there. However, I would like to bring our attention to the type 2, which actually could also be an aspect of managing an agile software development lifecycle when you're trying to accelerate development from one perspective, and you might actually need to take some trade-offs and make some suboptimal decisions for the longevity of the system, but when do you go back and manage those decisions? So from that perspective, it is the type 2 kind of debt that Steve McConnell has described that could be short-term, which means you pay it off quickly with refactors, or it's long-term, you'll maybe wait and see what happens in the industry or in the marketplace and go back to it later. But understanding both of these aspects, again, require eliciting, making it known to the entire team and stakeholders, and having a strategy going forward. The next that I'm going to highlight is work by Jim Highsmith, and this also goes to the heart of the approach that we're taking at the SCI as well, which is, at the end of the day, technical debt is about managing rework. What is the rework, and are you going to be able to understand the impact of that rework and be able to incorporate into your ongoing software development lifecycle? And Jim Highsmith describes it as cost of change and monitoring the cost of change. And as the years go by, because there are other, or as the iterations go by, because there are other kinds of changes that might be happening to the system, maybe new functionality added, maybe new technology upgrade, and so on, the cost of change might start increasing. And that's really what you would like to understand better to be able to manage the debt as a software development strategy. And that also goes to, are there any implications of the cost of change that require architectural changes? Are the changes or are the changes mostly local changes? And more often than not, when a particular symptom in a system is described as technical debt, it's not just the code that is really bad, but it's also accumulating problems that happen in terms of the architectural changes that have occurred throughout the system's development. And last, I will bring Philippe Coutin's perspective, which are, if you will, they are very complementary, but they really work towards the opening position that I put forward, which is, can we really describe and quantify so that we can manage better? Philippe's perspective as well, when we're developing the system, we focus on the value, which could be the visible features that have a benefit to this, immediate benefit to the stakeholder. We also do have a good grasp of the negative value, which is the visible defects that we need to make sure are resolved before the system is out. However, most of the time, the ones that go unrecognized is the hidden aspects, the invisible aspects, which tend to be the architectural features that do actually bring value, and also the technical debt, which if we are not aware of it and if we don't specify it in our backlogs, we're not able to manage and pay it.
Okay, folks, we're going to do a quick polling question here that will pop up on your screen in a moment. The question is, which of these areas do you observe technical debt the most? Option 1 is code. Our code has become very hard to maintain due to clones, cycles, random bug fixes. Architecture. We have made suboptimal architecture decisions that we need to re-architect soon. Process. We have skipped practices such as reviews, necessary testing, and documentation that we are paying for now. All of the above or none of the above. So we'll wait about another 20 seconds for everyone to vote, and then we'll push the results live. Okay. And the results, we were at 13.3% with code, 20.5% with architecture, 17.2% with process, almost 45% with all of the above, and 5% with none of the above. Any surprises there, Ipek?
Oh, well, I actually, all of the above I was expecting, but I actually thought people would be drawn to code more, so this actually validates the position we're taking with our work that architecture could actually help manage and, in fact, be a driver for accelerated development using technical debt as a software engineering practice in moving forward in the system development. So let's press on. What can we do? There are only three avenues to take. We can do nothing. It might get worse, but it could very well be a zero-interest lifelong loan. So it's really being able to understand what doing nothing really means in that case. We could replace the whole system, which obviously might have high cost and risk associated to it, but in some cases, it could actually be the fact that that's what might be needed, maybe giving the system its own death before replacing it, or we could do incremental refactoring. And actually, architecture becomes really an instrument when you take the incremental refactoring aspect to this. And I'm going to go through some examples, both from ours and also from some of the literature out there. Earlier work by Dene and Huang have actually described the decision of taking dev quite well. The whole point of going into technical debt could actually be a very well strategic decision. You want to put something out there into the market and get the feedback. Not all the systems have that luxury. And in fact, our DoD stakeholders do not always have that position because of all the assurance and validation and verification activities that go around it. However, even in that context, being able to put out some working system early to get stakeholder feedback, even it might be with a small set of stakeholders, could really have a lot of positive outcome for the learning. And Marianne already talked about some of the aspects of the collaborations and the prototyping and the contributions to the learning. So it's really being able to understand where is the self-funding point of the system and how do you move forward from that point on. Overall, the decision to take on debt and managing it is actually a decision management problem. What has typically have happened is, well, if we have a particular amount of money to spend on the system, we could all spend it and develop the system, which is a traditional phase-based delivery approach. You put the system out there, well, and you assume there's a 50-50 chance that the market might love it, you might take the benefits, or it might completely fail. What has been happening more often than not in large-scale systems is spending that number of years before putting the system out there actually has much more detrimental effect. So in that case, using technical debt as a strategy, as dividing the system delivery into chunks, might again have an advantage. So the typical model for using in this approach has been, well, then let's divide the investment into two, put a portion of the system out there, and again, there's 50-50 chance that the market might love it or might not like it. And then based on the probabilities, we have a simple net present value calculation, and then we recognize the value. Well, what happens here is it appears as if technical debt has increased the system value. And this is where some of the proponents of accelerating delivery without going into the architectural foundations of the systems have gone wrong, and that's where actually the refactoring and the technical debt really gets them big time, because the rework cost of change has not been factored into this kind of an approach. So what really needs to be thought through is, well, we take a portion of the system, we put it out there, or we put it out for prototyping, whatever the context might be. It could be going into some of the assurance activities as you continue to deliver the rest of the system. However, the reason for doing is to really increase the chance to success. So you need to take on debt when you know putting the system out there will increase your chances for getting the market feedback. And that goes back to understanding the probabilities of whether the market likes or does not like the system out there. And then once the market feedback has been positive, it's not the remaining part of the investment we're talking about. In fact, it is the interest, the debt, and the interest that accumulated on the debt that needs to be considered as well. So the value here is actually, it's both the debt and the interest, and there's more high chances of success because you're understanding both the probabilities and the aspects of the decisions that you take. So what we're actually suggesting is it's really a decision model, and it's not necessarily always negative. It could very well be options with different outcomes that you might investigate throughout the development life cycle. The advantage of taking a decision modeling perspective is technology upgrades could actually then maybe easier integrate it into the software development life cycle, and the trade-offs could be calculated accordingly. How do we track and analyze that? And that's actually the devil is always in the details, and that's where we as the software engineering industry has not really done very well. We talk about it as a metaphor. It has become an extremely powerful tool for communicating, especially between folks who need to improve their systems in terms of the technical perspective versus management perspective, yet still it's not necessarily a repeatable and measurable practice, and the software engineering foundations that we could actually take advantage of are there. Some of the factors to consider could be defects, if there are increasing amounts of defects in particular areas of the system, changing velocity, changing cost of rework that you might be incurring could start giving some indications if, in fact, debt was not strategically taken on, or on the other hand, if debt was strategically taken on, but you didn't know when to pay it back. You could map such indicators into cost of development and understand and compare the value of paying back debt versus not paying it back. I will come back to the analysis tool. So the tracking and monitoring aspects have always focused on, in a way, coming after the agile software development proponents. Well, first we do more capabilities, and then we add more infrastructure, and there is an anticipated re-architecting cost. True, we've seen many, many examples of such. However, taking an upfront, develop the whole system perspective has depth on its own as well because of the neglected cost of delay to market. And I'm sure everyone has in their back pocket a war story where you've spent a number of years, so many developers and costs without being able to put the system out there, or the system was out there but nobody really cared about it. So it's really being able to understand how we track and monitor what's happening and which path to walk through as we go through the systems development and lifecycle. The agilistas will recognize this figure, which is we start with developing functionality. The first couple of iterations were all happy campers. Yet, as we go further down the development path, somebody comes and says, well, obviously it has to be secure. Well, the performance needs to be really so that we can scale up to 10,000 concurrent users and whatnot. And then introducing those architectural requirements later starts showing its impact by detrimentally reducing velocity, hence as technical debt, which actually has been the story that the Agile folks has described. I will also argue that this also is an example of technical debt, which is the phase-based focus. You spend number of iterations understanding the requirements, architecture, analysis, and whatnot, with the hope that your development will spike. Well, it might spike, but oftentimes that kind of feedback actually comes late, and you might be in the position where you are not able to react to it timely as well. So the bottom line of the work, and I will just present this briefly, and in our slide deck there are references that you could look more into. It's really how do we quantify it? And the quantification could go into both code, but we are more interested in quantifying it early on in a continuous way and understanding the impact of rework that is accumulating in the system. So what our work focuses on is understanding the right set of architecture models that we could actually use seamlessly within the Agile software development lifecycle to give feedback to the development team and understanding what might be the impact of rework. And here, understand that the rework may not necessarily be planned for. It could come back as maybe a change of requirements. It could come back as change of technology. But if we have the artifacts accumulated, can we really factor out and map the cost of change to those artifacts? So it's really being able to understand that optimum development path to follow and balance agility and discipline and architecture-focused development at scale. This is a good segue for me to spend some time in terms of what's been happening out there with tools and analysis techniques. And when Marianne asked her polling question, we saw that there is actually a significant number of folks out there listening to us today who come from consultant and tool vendor spaces. So they will probably appreciate this as well. So there is an increasing trend in trying to bring some structural analysis to the software's understanding depth. There's increasing sophistication. There's increasing understanding for, well, it's not only just the code, but what is the structural analysis that we need to take into account? And also, how can we now start layering the foundations that the depth metaphor has been so appealing to folks in terms of interest, it's in terms of the monetary nature that we have to structure for the remaining part of the iterations. There are some architecture-related capabilities out there. There's an increasing sophistication in terms of architecture visualization techniques. I apologize. Architecture quality analysis metrics and compliance checking in terms of between the architecture and the code, and also providing an architectural sandbox with various tools, for example, introducing patterns and being able to manipulate some of the aspects of the architecture through those, in addition to other compliance and quality analysis methods. With the visualization techniques, the one that has actually been mostly utilized throughout the tool space has been design structure matrices and the dependency graphs. That's obviously a very powerful tool because it can help you do some change propagation analysis, some reuse analysis, and all the kinds of analysis that the quality attributes such as extensibility, scalability, whatnot could bring at both development time and the module view of the software architecture. There is also support for conceptual architecture in terms of showing views. And one particular pattern has emerged as architecture layers and showing rule violations among layers. Why is this an exciting development? Because it's really starting to bring some of the architecture practices to mainstream. What has actually happened is it's been really embraced by some domains when it's safety critical, but we're increasingly seeing that even if it has not been a safety critical system, in DoD systems, and Terry Takai talked about that, even the IT systems have a lot of actually aspects that go with some of the safety critical systems that have been out there in terms of their reliability and performance requirements. And some of the architecture quality analysis metrics that come with it are cyclicity, component dependencies, and architecture rule compliance, and somewhat a way to put some financial figures in terms of the debt analysis. And I give some examples to the tools out there. And as I said, it's exciting that there are a number of folks out there. And however, the effectiveness of these techniques will only emerge as we learn more from them and as we push their boundaries more. And there are a lot of skepticism, including with the perspective we take on our work, in terms of whether precision is really the way to go, or how can we really put some 80-20 analysis to what we learned from the code static analysis metrics and move forward with some of the analysis that comes with it. And the whole point of providing some structured analysis with some tool support or with some quantification and at least description of the data is really being able to move forward with a strategy to pay down the debt. And again, it's really what are the indicators in the system that you could define for your domain, and how do you monitor those indicators? Increased amount of defects, that's an obvious one, or oftentimes it's sadly not even being able to deliver the system out there, which actually does happen in some systems that have quite a number of large stakeholders or different teams that need to rally around the development effort. Slowing rate of velocity, and again, at the first sign of slowing rate of velocity, it could actually be a very easy thing to do to visit the implications in a retrospective and take note and move forward. That even has a long way to go in terms of helping how to manage the implications. The change of business and technology context is a harder one because oftentimes we don't even recognize that the change of business and technology context may all of a sudden put us with an unexpected load of debt. And this again could very easily go back to the financial analogy, which could be a flexible interest rate. All of a sudden the markets change and the interest rates rise upon us and put us in a situation where we didn't expect. So understanding those changing conditions and revisiting what's happening with the system in terms of cost of change and rework as an analogy for managing technical debt could actually be a way to understand whether it should be paid down or not. And some strategies and techniques for large-scale systems, and not all systems will necessarily need to deal with this, but for large-scale systems, adding technical debt to the backlog, if you're using backlog for your iteration planning, and continuously monitoring should be a common practice. You could then decide on particular strategies based on your team. For example, decide to amortize 10% based on a particular tempo or release cycle, or you could have specialized iterations. For example, focus one particular iteration, just paying back the debt. They're all strategies that could have advantages depending on the team structure and the domain. We've also found out there are some architectural tactics that can help, and you can read more about it in our recent paper in Crosstalk, but I will very briefly give a highlight. What we've observed that is teams developing systems in an agile techniques tend to actually start off having different architectural decompositions compared to teams that have a more phase-based waterfall focus. That is, of course, expected, but in some cases, you could use that to your advantage in terms of understanding whether the decomposition of the system will need to be more feature-based or quality-based, and how will that incur depth or accelerate development. There are, for larger scale systems, spending the first couple of months creating an architecture runway where the development teams could sprint upon, or actually has become a typical technique that some folks that are developing systems for more embedded type, real-time embedded systems have used. And the last one, the matrix teams, we've seen for especially some commercial industry, increasing number of teams, especially if you're using Scrum techniques. You can actually take advantage of some specialized skills, architecture being one of them, and move your architects around teams as you need to focus on both architecting or re-architecting to pay back technical debt. And one thing to recognize when you're developing these strategies is the value will decrease over time in terms of what particular iteration that you might assign a feature to. And on the contrary, when you are paying back technical debt, the amount of resources spent on paying back might increase as you push it forward throughout iterations. That all becomes an aspect of doing the release planning and iteration planning continuously. And if you haven't really quantified and made the technical debt known, you could not actually make such decisions or analysis on top of this. Very quickly, some open areas of investigation that drive our work. Obviously, the notion of technical debt very succinctly communicates the issues observed in especially large-scale long-term projects because of the changes that are involved in it. There is an optimization problem where we need to focus on the decisions between short-term and long-term and understand what are the trade-offs that are made. And architecture, quality attribute reasoning could become a very powerful tool to make those trade-offs and make them known. Design shortcuts often give the perception that there is success. You cannot just look at what's happening today. You have to look forward at least a couple iterations or whatever the timeline of the system is and plan accordingly. And take into account some of the architectural ones that might need to change. And there also most of our work, at least in the coming year, will continue to focus on what might be some opportunities to better quantify and develop payback strategies, because that really is at the heart of the overall problem. And I'm going to leave us all with some of the things that we can do now, which is the first one, make technical debt visible. Even if it's just describing that there's a problem, it becomes important to make it visible. And differentiate the strategic technical debt that was done intentionally from the low-code quality bad engineering practices or the processes that have not been followed well, because there are different techniques that you will bring to bear for managing with them all. And associate technical debt with risk, because the payback strategies really goes back to what is the business risks that you are willing to take on and how the business will bear some of the consequences. The last thing that I want to leave us all with is we've moved a long way from the Agile Manifesto and the architecture proposition, which actually defined the last decade of the software development techniques. Obviously, the most important aspect of a project is being able to deliver working code that meets its business and quality goals. And those words actually has proven itself to be not necessarily helpful to the software engineering practice. It's really the integrated approach for large-scale systems that we're moving forward in terms of how do we balance anticipation and adaptation, which is the flexibility of the systems, and also how much you can plan forward for. And in fact, understanding the software engineering foundations of technical debt could help us go a long way in that regard. With that, I'm going to close today, Shane, and we have our references. I'm happy to, I think I have a couple minutes to take questions. And
great, Ipek. Thank you very much for your presentation. We'll get right into the questions. And the first one from Orhan asking, how can one balance between being debt-free and over-engineering the system at the beginning of the project?
Oh, that's a hard question, and it's a very good one. So at the beginning of the project, it really goes back to the business goals. We've found over and over again a lack of good understanding of the business goals when the systems are developed. And this actually speaks to both commercial and our government stakeholders. Not understanding the business goals result in not being able to make those trade-offs. So if the goal is to really be able to move the system quickly out there, that actually all of a sudden could eliminate a lot of the things that could be done. If it's to save money, again, that could eliminate a lot of options. Or if it's really to be the innovator in the marketplace, that might again eliminate some options and open up other ones. So I would really focus on business goals to start with and move the architectural decisions out.
Okay, excellent. Next question from Ronnie asking, can you relate reduction of technical debt to specific Agile processes? That is, what specific areas in Agile can I concentrate on that will give the most reduction capability on technical debt?
Well, I think that's a question that could be answered with a lot of practices. But one of the things that from the collaboration arenas, at least I've been following, and also some of our work has also focused on, is making technical debt explicit if you're using, for example, Scrum in your Scrum backlog, If you're using Kanban, maybe making it known with whatever techniques you might have, if those are some of the agile lean techniques you're using. And even that itself could actually start opening up some opportunities. Then there could also be a lot of technical aspects that go with the types or the notion, the kind of depth that we're talking about. But I think making it known is the number one thing that I would include it in the backlog once, one way or another. Flips, what color is your backlog, is, I think, a powerful technique to start thinking about from that perspective.
Okay, next question from Thatch asking, what is the difference between taking on intentional technical debt and making the market beta testers? If you need a repeat, let me know.
No, well, I think there are a lot of similarities in there, because what you're saying when you say I'm going to make the market beta testers is I am agreeing upon some defects that I'm not going to really find and put it out there. I think the intentional aspects become important in terms of what you consider as defects and what you consider as particular design shortcuts. That's really where the difference could very well be, because defects, you don't want defects in your software. But a technical debt could very well be, well, I'm not necessarily going to make the system as distributed and use a distributed replicated cache. I'm going to go with one server, and then I'm going to move on to. So that might be the nature of the technical debt that goes in.
Okay, that's all the time we have for Ipek. Great presentation. Thank you. Folks, I know there's a lot of questions we didn't get to. Again, you can always send anything to info@sei.cmu.edu. We look forward to talking to you there.